Shri Gurubhyo Namaha. Namaskaram, friends. I'm back again to discuss the various concepts relating to the fundamentals of software engineering. We already discussed around 2-3 topics. So now we'll discuss a very interesting concept. I'll just share the screen. Okay, so we will be covering about software engineering, secure software engineering. We talked about the different aspects of what is the traditional software engineering, and we moved on to the different languages within the programming languages, the different generations of program languages, and how across the evolution cycle we are moving towards natural language uh, based programming using technologies of agentic AI, etc. So, bird's eye view on that now. Okay. So, we'll see how software 3.0 and why programming help the future of software engineering. Okay. So, uh, we will be covering on these topics the three eras of software engineering, the key evolutionary shifts uh, across the from historic shifts. So please refer to my earlier video on how software engineering has evolved over the years. When we talk about the historiographic tensions that or what to say of dilemmas rather we are currently facing, and overview of the software evolution mind map in terms of the emerging technologies, and how we move towards from software 2.0, 3.0 to the futuristic 4.0. At least what is the thought process among experts there. Okay, so that's how we would like to I mean focus in this session. Um, Okay, so we already discussed as part of the earlier sessions on what is software engineering, and moved on to the programming side of software. And we talked about different languages that are available, and all that comprises what today can be classified under the software 1.0 era, where it was all compiler or interpreter defined, way of programming. So where humans create the code, generate the code either in the good old days, as we already discussed, using textual editors, or through a more graphical IDE and integrated IDE environments where it generates some part of the code, but still the overall coding responsibility is with the human hands. So that is software 1.0, where we started building regular application programming, websites, mobile apps, middle tier applications, enterprise scale applications, and we walk through different kind of ecosystems like microservices and other kind of technologies. All that constitutes what is part of software 1.0, and we are still using those technologies as part of our development ecosystem. Okay, then as part of the evolution came software 2.0, which focuses or which is targeted specifically on the deep learning or the machine learning time, the data science related programming. Okay, that has been coined as software 2.0 era, and where it is more of a machine programmer specifically for statistical computing using deep learning and machine learning algorithms. Okay, So that era is our the recent past era where there was a lot of boom in the data science domain for statistical specialists, data scientists, data analysts, and programmers using some of these technologies related to deep learning, neural networks, and machine learning technologies, right? Uh, so with with that, we move on to the next era, which is the now on here happening now on here right now here it is happening actually. So it is called as the software 3.0, where the programming paradigm has shifted to natural language. Okay, so while in software 1.0, the focus we already saw started with the typical machine machine code, okay, and then as a first generation programming, okay, then there was assembly language, machine language, assembly language, etc. And then there are the procedural languages like C, COBOL, etc. And then came in object oriented programming styles based on languages like C++, Smalltalk, etc. So object orientation, as I already discussed, in my opinion, is the is the pre-runner to today's AI related lot of concepts. Please refer back to my earlier video where I shared some of my opinions there, particularly the language C++. It's the way object orientation helps in orienting our programming style towards the real objects. So the real objects are digitized into the computer model using C++ programming constructs. So for last 20, 25 years or 30 years, C++ has been so powerful in helping uh, simulate the physical objects as part of the programming domain. But while it is confined to programming domain, this is actually a similar concept to the current trend of AI, where we are talking about modeling the real world into the digital world. All these high end concepts of digital twins, where we have a digital replica of a physical object. So all the concepts of oops play in a critical, I mean, play in a similar role at a language level. That's all we discuss as part of the software 1.0, right? And that has today evolved into the software 2.0, where instead of the programming as a procedural or object oriented programming or the scripting based programming, we start uh, dealing more with the data intensive programming as part of software 2.0, where it is more for deep learning and training the machine to learn from data samples, right? So that was the focus in software 2.0. Software 3.0 evolved into a natural language space, where currently we are using AI, generative AI technologies combined with agentic AI to generate programs through a channel of prompting. So we also talked about different kinds of prompting, right? Regular prompting now is moving to what is called as context prompting. So we add context sensitivity to our prompting, so that the generated code is closer to the actual requirements that we want. So natural language programming involves natural language uh, processing, because it has to understand our language, the natural language, as part of the prompting, and then natural language processing, understanding, and natural language generation. So all these domains are needed as part of the software 3.0 revolution, where the programming language is going to be regular spoken English, and that but still the machine needs to understand some of the languages, just as how we saw when we discussed about the compiler based languages, the higher level languages where uh, the human readable syntax has to be converted or compiled into a machine generatable or machine executable syntax, where the compiler converts uh, the source code into an executable form. And then we saw how the virtual machines came in with bytecode concepts, which will help porting across multiple platforms with the Java and other kind of languages, helping that kind of portability. Okay, now here what is happening is that coming back to software 3.0, the language that which we communicate to the computer is going to be English language through context sensitive prompting, which is technically called as context engineering now. So, and what the system currently generates is that it generates the source code compliant to either software 1.0 code base, like it could be a Node or JavaScript or Node.js code base, it could be a Python code base, it could be a C++ Java code base. So it could be a typical application development code base referring to the software 1.0 era, or it could be deep learning and machine learning related Python code or R code needed for it. So today computer can generate this code through co-piloting with human assistance or on its own autonomous skills. So that is the focus of software 3.0, where natural language is used to generate the fifth generation programming language code, or I would say falling either under software 2.0 or software 3.0. Okay. So again, this gives you an analogy of software 1.0, where you write the source code in C, C++, Java. So there's a source code component. There's an executable or interpretable component which the computer understands. Then software 2.0, it was not the typical coding where like the C++ or COBOL or JavaScript coding syntax. Here it is more in terms of feature engineering of assigning weights. So it is more of a statistical language, or mathematical statistical way of tagging values to numbers and codes. And so the language paradigm changed here in 2.0, and in software 3.0 it is going to be pure human language as the first means of communication between man and machine. Okay, so software 1.0 is technically referring to the classical stack, which you already talked about, the different huge, repository of languages that we have cutting across the different use case domains. Okay. And then software 2.0 is called as the data revolution, where it is more sensitive to the data science related use cases and domains. Okay, so actually the term software 2.0 was coined by Andrej Karpathy. So he came up, he is a domain expert in this field, and he has come up with this interesting tagging for this era called a software 2.0, the machine learning and deep learning related software development. And he also is the person responsible for coining the term software 3.0 for what is happening today in the generative agentic AI, as the what he calls it as the cognitive AI revolution. So that is the era we are in today. Okay, so very closely related to the concept of software 3.0. Software 3.0 is underlying technical languages, its frameworks, its more modules, and its set of libraries, etc., and the skill set around it. Okay, there is a pattern of code generation leveraging these technologies of agentic AI to generate code. As I said, generate code, either a Java code or full stack code or whatever kind of code, right? using the latest kinds of IDEs which are integrated with the RAGs and agentic AI kind of plugins, which will generate the code on prompting for us. So there are a lot of tools like Replit, Cursor, Windsurf, etc. So these are all very widely being used. So this pattern of coding where machine plays a major role in generating the code. So it is, rather than machine assisted coding, it is machine is generating more and human is assisting it. So it is human assisted machine generated code. So that is what is today's era of vibe coding. I don't know who gave that name, but it's a very interesting name. This vibe coding is catching like fire. So we will deep dive into the vibe coding as a process in subsequent session. But I just wanted to introduce some of these jargons here. Okay. So the key evolutionary eras or the histographic timelines are we already saw about the history of software engineering across the four patterns. Okay, so we are currently in the phase of 2025, which is between 2020 and 2030, and we'll be moving more towards what is called as autonomous agentic uh, software engineering. Okay. So, a lot of slides. Okay. Just wanted to do a quick time check. Okay, the basic point I wanted to repeat here is that 1.2 to 2.0, the tension was rigidity versus agile stability. So 1.20, I think the era was more into cloud, right? From on-prem kind of environments, everything moved on to cloud. I think most of the IT landscape is hosted on cloud environment. All the workloads are mostly on a cloud infrastructure. It could be a public cloud, private cloud, or a hybrid model, right? And the processes around the SDLC is built in using a lot of DevOps life cycles, tools and technologies around that. So that is typically the evolution from 1.20 to 2.0. So the learnings of DevOps and the cloud got extended in 2.0, where the DevOps got enhanced to include the workloads around machine learning. So MLOps related life cycle for CI/CD, continuous development and integration workflows became the standard today. So MLOps is what is being adopted across all industries for streamlining their deep learning or machine learning processes. Uh, and then we have the autonomy and control versus from between 3.0 and 4.0 with the context engineering or the software 3.0 based vibe coding. Okay, there is a need for what is called as the LLM ops, or what is emerging as the agentic AI ops. So these are some of the eras there which we are here. So any technology, disruptive technology changes always has pros and cons from economic, social, and political and other parameters as well. So some of the great debates that is currently going on as part of a collective consciousness is one in terms of will if AI, agentic AI, is taking this world by storm in terms of replacing human skill set or capabilities or specializations in developing the software engineering cycle. So typically all parts of the software engineering cycle, right, from requirements templating, requirements documenting, to the design part. So generating design documents, creating design recommendations, tool set selections, and the actual coding part and the testing part. Today, the AI, agentic AI can replace a major chunk of human intensive works here. So then there comes a major question or challenge: what will happen to the huge, I mean, availability of the software engineers and the talent around them? If AI is going to replace them or not? I think this is a more debatable question with the pros and cons and challenges. End of the day, like any revolution at the technology level, there was always these kind of challenges, and the people who are able to adapt to the newer norms, right, of how the industry is facing, are able to not only survive or go through these grow through these transitions, right. So while there are people who get left behind because their adaptability to the new norm, uh, that is they which you cannot adapt to them, they are finding their own challenges in surviving. So these debates will always continue. I mean, one cannot give a boolean answer of yes or no, because both sides have the strengths and weaknesses. While the enterprises, the corporate world, or the employers perspective, they are able to quickly turn around better software, or at least faster software. So faster, I mean, their objectives in faster time to market and reduced cost of ownership, okay, are the key drivers for them to replace human resourcing with AI resourcing for their software engineering requirements. So this will happen whether we like it or not. So it is up to us, the survival of the fittest, right? So we need to see how best to leverage what is happening in the industry. Okay. So, but at the same time, I would like to highlight two things here, which as part of the going down, we will take a look at it. Okay. The second thing is yeah, the autonomous AI is making life impacting decisions. So it is almost penetrating to every aspect of our lifestyle. So we are talking about constitutional AI frameworks. Okay, AI will I mean, in the future, AI will become an independent legal entity, because it is becoming more agentic, right? So it can act on its own, it can know on its own, and it can implement and decide on its own. So it becomes I mean, while adding intelligence to it, we are also making it an independent entity to it. So there are pros and cons again from political, social aspects of it. Uh, okay. So then the dependency on cloud dependency versus latency on critical applications is another challenge. So because most of these technologies are now managed again by the cloud providers, are also the agentic AI providers. They are also the content providers. So I mean, there are going to be some kind of a vendor lock-in, like wherein everything is now either managed by Google or managed by Microsoft, right from my programming to my programs, to my code, to my data, to my everything, right? So that kind of what I would say is control also has its own pros and cons. So I don't want to get into the political side of the debates in this session, but these are all important topics which, as a collective consciousness, we need to take a decision, both at an individual level, corporate level, as well as at a government level. Okay, see, then more talking about the projected future, AI augmented software development life cycles is what is going to be the future in the next 3 years timeline at least. So where 80% of the code generation will be by AI, and DevSecOps will integrate into CI/CD pipelines and large language model pipelines, etc. Then then by the time of the early 30s, so there will be a lot of quantum based computing leveraged by these deep learning, particularly the large language models for quicker and more accurate results. So quantum computing, has been a parallel kind of trend in the industry. I think somewhere both AI and the quantum will start merging. We already see signs at a research level happening there. So almost all AI vendors are also focusing on quantum. So it becomes a very good synergy. Okay, so then that if I always it becomes autonomous R&D, right? The AI is not only a agent who can aid in humans. Then it becomes an agentic individual human with its own legal entity and its own mind, or whatever it is, right? When particularly when you talk about transhumanism, or we talk about digital singularity, transhumanism, all these though there is a larger span of time to reach the states, but somewhere down the line we'll reach a state where the machines, AI, the general AI, right, or it is called the AGI, right? General intelligence. So artificial general intelligence is where it takes the next leap in terms of its evolution. And further down, we talk about super intelligence, the artificial super intelligence. So these are all larger or longer milestones. But what it brings it is somehow towards an autonomy in terms of its thinking, particularly talking about the software development. It can play a role of scientist in coming up with its own solution. How today data scientists and the experts on the compute side are today, uh, providing a lot of insights of how we can improve the performance, improve the memory, etc. Right? So these researchers can tomorrow be supported by the machines itself. So we could see what is called as autonomous scientist, or agentic AI scientist, and all that terms, right? And so there's a lot of need for regulatory governance here. The checks and balance of how much of control we need to give to these machines. End of the day, they are machines. So those are more of ethical or philosophical questions which are gaining a lot of momentum. So I will have a separate session specifically talking about the philosophical and the metaphysical, psychological, consciousness, theory of mind related topics, and AI, which are now getting a lot of momentum these days. This is another view, a mind map view for AI, the future of software evolution. So there is going to be just to, so whether it talks about the CI/CD pipelines, we already talked about. From MLOps, we are going to move to agentic operations support, right? And then we are also talking about the different kinds of technologies in that space. Okay, so uh, this is just whatever we discussed about, right? It gives a mind map view, right? This is again generated by AI. So AI is now an integral part of everything for us. Okay, so the core benefits and characteristics of software 3.0 is larger program space. Okay, unlike in the traditional software 1.0, where the human skill set of specializing on a language core, right? As we already discussed in the earlier session, uh, there was a need for specialists on a specific language, like for example, a specialist in C++, specialist in C, or Java, or C Sharp, or Python. Kind of specialists were needed, or on a database, or like a SQL database, or on a new SQL. So there were DB architect specialists who had not only rich experience in creating or enterprise scale software. So there was also a knowledge curve of where they started specializing, either through various certifications or through direct experience on hands-on experiences. etc. There was a specialization built. There are special professionals who are focusing on building those softwares, and they demanded a very high premium price in the market. To sell their services of software development, right? But that is changed today. So that era is changed. With those skill sets are now replaced by machines. So I don't need to remember the source code and the syntax of the code. While we started programming, for example, when I started programming during the C++ days, there were not much of internet available. There was not much of online help or IDE generated help available on the syntax. So most of the time we need to either remember it, or we have to trial and error, find out what is the syntax, or try to take a photocopy or xerox of some book on that which is very heavily priced. Take a xerox, see the syntax, and then try it out. That's how our programming learning curve started. But with the last 10-20 years, with very powerful IDEs, the remembering the syntax got reduced. I need to focus only on the programming logic, or on the designing or the architecting side of things, while the coding syntax, the IDE helped me. And when it comes to natural language, I don't even need to remember or know all these things. All I need is regular human language, and as long as I can give a context sensitive prompt to this AI machines, they can recognize it, and I can iterate to build generate the output that I need using these context engineering techniques, right? So the skill set is more of an art now, where it was like a science. Right now it is becoming an art. If I could if you could engage with the AI in the right way by giving the right requirements, so when I build efficient communication with the system, I generate the right output. So it is like the garbage in, garbage out kind of a technology, right? If my prompting is bad, or if my way I am giving instruction to the computer is bad, the generated code will also be equally inefficient, or bad. So, but the dependency of several years of expertise on the actual skill on the language itself, like Java or C++ or JavaScript, etc., is no longer needed, because no longer needed to the level it was there. Right today, the code is generated by the system. As long as I am able to make sense of the generated code, I'm happy with that, right? So I'm still under control. Okay. So that is the advantage where we are talking about the larger program space. So I have more space now to focus on the actual business requirements, or on the actual tuning of the designing and the architecting part, rather than the syntax or the semantics of a language, right? Then the enhanced explainability and interoperability, right? So while 1.0 needed a lot of learning curve, 2.0 also needed learning curve. Plus, it was also more of a black box, in the sense that it was not understood by a layman. We need a lot of statistical modeling. You need to be an expert in statistical techniques to understand all these classification, regression, and all these concepts to work with that. Right. And software 3.0 is, again, it is going to be human language, right? Spoken languages, natural languages. So that eases our thing. Then increased adaptability. It is easier for human developer to learn. So here there's nothing learning of a special syntax. Of if somebody wants to learn C++, there is a very calculatable learning curve there, when he wants to fully understand the length, breadth, and depth of language like C++ or J2E, or C sharp, right? But that is in here. So the faster time to learn. Okay, then democratizing of programming. Like, again, we said that there. So high salaried jobs was a focus of people coming out of the IITs, or from the premier BTech or MTech graduates, only because they had a rigor of the experience on software engineering, and with a lot of experience from these companies. But today, I think the market is open wide. Anybody who can, smart kid who can generate the right kind of code using whatever tools, as long as he is able to get an output which satisfies the business requirements. I think they are hired, right? So that kind of flexibility of democratization in terms of anybody, the market is open to anybody, right? See, I also heard of use cases, I mean, scenarios where people from a different line, people from a business or MBAs or who are practicing sales side have now moved into this prompt engineering, web programming. So it was very surprising news. So all he said is that, I mean, I know I have been dealing a lot with from a business analyst side or from the sales side. I understand the requirements well. Now all I have to do to communicate to the computer, and the computer generates the code, and then I have some ways of sanitizing the code, and then I'm good to go. So that's how the trend is today. Okay. So, so again, the difference between the three eras, the classical stack is more of a human authored code, which already talked about it. Here, 2.0, it is more of data modeling and training, which is more of a statistical way. Software 3.0 is more cognitive, where it is more of human spoken reasoning that is given. So that's a mutual reasoning. The prompter or the context engineer also to give a reasoned out requirements, which using various technologies, the system like chain of thought, graph of thought, and various kind of hierarchical model, it builds the reasoning context. And once the context is built using various RAG and other kind of technologies, it pulls data from upstream, downstream, and wherever kind of streams. So aggregates the content and gives us the generated output, right? Then comes the primary artifact is the source code when it comes to 1.0. 2.0, it is more of the statistical parameters of when basically the neural network weights. Okay. uh, Here it is going to be a hybrid, because the software 3.0 caters to both the software 1.0 code base as well as to software 2.0 code base. So I mean, in other words, I can generate neural network weights using software 3.0, or I can generate a Java or Python code also using the same software 3.0, right? So it provides a hybrid model. And then there's a developer role where the developer takes the heavy weight in terms of software 1.0. In software 2.0, it is not the developer, it is more of a data curator or a data analyst, or a machine learning engineer who plays a major role. So from a software engineer to machine learning engineer, we move towards what is called as a agentic engineer or agent orchestrator or AI engineer, or whatever fancy names you want to come up with. Okay. So then comes the development process. A typical software 1.0, which was waterfall and agile, with the DevSecOps pipelines for their continuous development, integration, and continuous security kind of a thing. When it comes to MLOps, it is more of I mean, software 2.0, it is more of a data model centric, where it's data cleansing, data training, and the data runtime, all those things which are part of the regular MLOps life cycle are now the core of 2.0. Agentic DevOps again talks about how the integration between agents is happening, how the data flowing, how the instructions is flowing, etc. So all that is becoming part of the agentic or LLM operations, right? LLM op is the talk of the town here now again, right? Then moving on to key technologies, we saw that software 1.0 focus more on the compilers, then interpreters, then it was more IDE generation, etc. And there are huge set of tools and technologies, open source, non-open source, when it comes to software 1.0, because there are a lot of technologies there, C, C++, Java, Python, uh, and I mean, Flutter, all kinds of technologies. Each has their own set of libraries and executables. So there's a huge repository there. When it comes to software 2.0, it is again technologies around. We already saw what is the machine learning technologies and all, but here the focus is on more of the integration through MLOps and the TensorFlow for the orchestration and other things. And hardware, while CPUs was the core hardware for software in 1.0 workloads, GPUs or TPUs are what are used here in 2.0. Software 3.0 is again hybrid. It depends on what you are generating. It could be a GPU for a GPU for a CPU, TPU, or it could also be on the quantum machines, right? And when it comes to software 3.0, the new paradigms of technologies are like the RAG, the RAG, the vector databases, the A2A, agent to agent protocols, etc. So these are some of the, I mean, chunking, embedding related kind of technologies are all are what the technologies in demand, right? So core limitations we already talked about. The next important point is that large language models are becoming the new operating system when it comes to software 3.0. I mean, not technically an operating system, but it plays the role of an operating system. It means that everything is centering around it. So there is the core pre-trained conditions of an LLM model, which is a primary source of input, and we have other upstream and downstream data pulled for context reasons. So this context sensitive data aggregation from various upstream downstream systems from an enterprise through technologies like RAG, or through technologies like MCP. MCP is more of a protocol, and RAG is more like a technology background for it, and A2A kind of things. LLM is becoming the main backbone or operating system, the heart of the entire agentic AI ecosystem, right? So we are talking about AI agents, which are replica of human agencies. So they are substitute, they are competitors, however you want to look at it, for uh, competing the same and supplying and at many times excelling the human intelligence. But there are use cases where I mean no machine can meet forget beat, not even meet a human intelligence, at least in today's terms, right? So the but for all other practical use cases, AI agents are great contender in the race. Then from a traditional relational model in software 1.0 to the NoSQL paradigms, where we have object databases, JSON databases, graph databases, time series databases, columnar databases, and these graph databases. Graph databases becoming more powerful, particularly in today's context of where the complexity of information or the big data, large kind of social network based, right? Where knowledge graph model provides a many to many relationship, unlike a relational model which provides only a one to many relationship. RAG graphs are becoming very, very popular. So there are knowledge graphs and there is RAG. So RAG is based more of a vector based for the for the chunking of the data and vectorizing it. So the RAG is more a vector based database, and then there are knowledge graphs which provide you the context around the relations between the real time entities. Um, Again, there's a cognitive aspect to it, from a regular system of records to a system of reasoning. That is where we are moving. So in fact, if you talk about large language models, they themselves are evolving into what is called as large concept models, which Meta is trying to push through it. And there is something called as large reasoning models, LRMs, etc. So LLM, LRM, LCM, these are all the new paradigms in which the cognitive thread is evolving, each trying to provide an edge over other in certain aspects. Okay, so I have a separate session on that where we will be discussing that. And then we are talking about the human agent interface where the agency are becoming as intelligent as human, and it is more of intelligence integration, unlike in the other case of traditional where it is human intelligence versus a dumb interface, right? So we generally used to talk about we are communicating with the idiot box, but the idiot box is no longer an idiot box. So it is now independently able to think through, right? And so long as it doesn't make us an idiot, we are fine with that, right? So this is again a summary of the near term, mid term, and the long term journey of from today's state of 2025. So where there's more of agentic orchestration era, we the middle term in the next say 5 years or 5 to 10 years, I would say, is the rise of autonomous or meta companies where uh, they build agentic. Systems which are independent on their own, right? So they are able to manage things on their own. So that is where the industry is moving towards. Okay. So agentic orchestration, which is into fully autonomous software companies, will move from theory to reality. It will become possible to create meta companies. Already, Facebook has named itself as Meta, and it is pushing all these concept of large, what to say, concept models, etc. Right, and it is in a hiring spree. Right, it is left, right, and center. It is hiring scientists, developers, specialists, engineers, researchers on AI space from almost all its competitors, be it from Microsoft or be it from OpenAI or Google or or any of these companies, right? Uh, right. So so the human developer role will continue to ascend as we move along. Okay. Then there will be the long-term goal, wherein in the long term we'll begin to see future instantiation of the software 4.0. So this is again, we don't know when will it happen and what will be the main aspects of it. But let's wait and see. Large scale decentralization of autonomous. So first we build orchestration about agents. Then they collectively become autonomous as part of the midterm, and the long term again we start decentralizing or specializing them into another large areas of scope. This is again another historical context of uh, what we have been discussing. So right from the time of software 1.0 started in 1960s, right? So all through the year, there are different milestones. I mean, as we already discussed it, I just wanted to skip through to look on these areas where there is a lot of focus on legal AI citizen. This is a very interesting area, as I already talked about. So agentic AI can represent itself legally. I mean, this is not new as a non-human being getting a legal citizenship, right? Today, any corporate is a legal entity, right? So there are a lot of legal entities by them. So legally, they are separate individuals, right? Like that, an agentic AI which is able to act on its own, know on its own, and influence on its own, right? So those things will soon get its own citizenship. At least that is what the predictions are. Okay. So then there is a global swarm of agentic AI across the globe. Every vendor wants to be part of this race where they own the larger share of agentic AI, and so that's how the need for regulatory compliance becomes more mandatory. The ethics, so which is the most neglected subject in the entire domain of learning in these days, right? Is becoming much more crucial. So ethics related ecosystems have to be brought in where Otherwise, we get into the dangers of machine overpowering man. Right. So now I wanted to get back to with this all this background to what is vibe coding. So vibe coding, we already saw that it is using agentic AI to generate code. Okay. So the interesting aspect is that we already saw the advantage of that is that it reduces the total cost of ownership from the corporate sides, say the software vendors or the software creators, because they get cheaper labor now on who are able to smartly prompt, right? Those kind of things are happening, but at the same time, so the traditional workforce needs to be replaced at lower cost. So that is what, for example, Cognizant came up with the news very recently saying that it aims to generate 50% of its code using AI within a year, right? So that's what it means, that 50% of its code is going to be generated by AI. Right, when I mean companies human generate code itself, we know, I mean, the pros and cons, right? So we are he's talking about a scale of 50% of that code. Okay, I mean, however soon it happens, but sometime soon it will happen. For example, this is the official news here, right, from Cognizant. Okay, so this is exactly the news where it says that Cognizant aims to generate 50% of its code, which makes sense, right? From our employer point of view, for faster time to market and for lowering cost, they are doing it. They will do it. Okay. So, and from what happens from a developer point of view? From a developer point of view, again, if you look at it, it becomes slightly tricky. Um, So when it comes to a developer point of view, again it becomes slightly tricky. First, it gives him a very cool face, wherein I mean, all these days we have to day and night write code, compile it, do the bug fixing. But today I can coolly relax and say build an app, and I will check it later, right? So it is making me much more cooler, or we call it as lazier or cooler or smarter or whatever way we look at it. But over the time, what happens is that we become too dependent on these machines itself, and we lose our own individuality, the actual specializations that we were banking upon, or we are selling from our side, right? So even though there is something very easier to know, we take a longer route because we are too lazy to do the work on our own, right? We are dependent on the tool for that. This has already happened to us, right? It is happening with various technology revolutions. Earlier we used to remember all numbers and names and other things in our mind. Then it became everything is managed within my smartphone. So and I stopped even remembering things, right? So that kind of pros and cons are there. Okay. So and then another major challenge is when I write the code, I have full control of it. So the debugging becomes much more easier for me, because I know what is there, which logic is written where. But when computer generates the code, I mean, God save us. So it becomes very complex because it just throws a raw code for us to consume, for fixing. So this is typically happening in a lot of industries, right? I mean, the tools, low code, no code kind of tools generate a lot of code. So the coding time is reduced as part of SDLC cycle, but the debugging or the testing time drastically increases, because to fixing the code, the knowledge for finding where the code is bugging again becomes a very there is an operational challenge there. Okay. Another major news, while we saw a positive side of the news where companies, there's a lot of demand for vibe programmers, and 50% of the code will be vibe and all that, right? So there's also a parallel news already happening. Replit, we saw, is one of the major providers, ecosystem in providing this vibe coding platform, right? IDE to end-to-end support, right? So a recent case study talks about the coding tool deletes the entire company's database, right? Because I mean, we should understand the AI is just taking its baby steps, right? So if you give too much power, uncontrolled power to a baby, it doesn't know what it does, right? I mean, no use blaming the baby. So, but the risk is there, and the risk is already being felt. That the pain is already being felt here. Okay, this is again a news from the industry. So AI goes rogue. So Economic Times Replit coding deletes it, and in fact, the Replit owner also admitted that, and he confessed for that, and he said that it will not repeat or whatever that kind, right? But we should be aware of these kind of challenges. Okay. So the key evolutionary shifts is from syntax to data in between 1.0 to 3.0. Okay, and again the control of autonomy we talked about, hardware software configurations where neomorphic chips are getting there again in a future case, right? So we started with the hardcore textual programming, then IDE generated programming. From there we moved on to the prompting or natural language program, where I need to go to a chatbot console and give the instructions, uh, or a CLI interface and give the integration, or an IDE and give a written instruction or a prompt. From that, the code is generated. Okay, and soon that will be changed into voice based prompting, because speech recognition is another parallel initiative in the AI space, and I think these two are already getting merged. And all I need to do is to orally instruct the computer, the agentic AI, which will generate the code for me. So that stage will also evolve towards what is the neomorphic chips inside the brain. Right, today they are trying to implant a chip inside my brain, human brain, and the digital singularity between man machine, the transhumanism, right? Where even my thoughts can generate the code. At least that is what the theory is moving towards, the future of AI, right? So all these things are leading to some of the ethical challenges we touched about. Okay, so with this, I just wanted to close the discussion on this. These are very very what to say, bird's eye view kind of insights, conceptual insights, I would say, in terms of uh, software 3.0. Hope it helps. So I mean, this is a learning curve for all of us. This is something new for all of us, and it's a very interesting domain where science meets engineering, meets psychology, meets philosophy, meets ethics. So it becomes an integrated topic to learn, discuss, and share. All right. So let's continue these discussions for the other regular cycles. So some of these topics that we talked about, I'll be having separate sessions where I'll be sharing my 2 cents. Okay, so stay tuned and do share your feedback, which is constructive feedback, uh, which will help me critically tuning these requests. So just as an agentic AI autonomously tunes itself based on feedback, so I think we can also tune ourselves. Instead of being an artificial agent, we are all human agents, and we have the capability of learning from feedback, right? So let us see how it goes. So do share the videos to your friends, and also be do subscribe and like it, so that the motivation is up and going on in this knowledge sharing exercise. Okay, thanks a lot. Okay, so let's meet again. Okay, so I'll stop sharing. Okay, so thanks again, friends. Let's meet up again in the next session. You can always reach out to me any of these channels available either through the social network sites or through email. Okay, so wherever I have provided my
touch points, access touch points, you can reach out to me. Thanks, guys. Thanks all. Shri Gurubhyo Namaha. Thank you.